volume. So the first thing we're going to look at is we're going to look at the surface area of a rectangular solid. Okay, so we're primarily looking at volumes, but surface area and volumes. Okay, this is basically 3D. So this is the front of a rectangular cube, and so I'm going to copy it and paste it, and now we have a back of the rectangular cube, and here are the sides, and this is so you can see right through it, right? So, all right. So we're working in 3 dimensions here, 3D. So if we want the volume, let's assume actually, as I move through all of this, that V will be volume and S will be surface area. So for this section, we are going to let the letter V represent volume, and S is going to represent surface area. Okay, this is for just this section here. Okay, so the volume for this is its base times its height. Base times height. Now let's take a look at the base. Let's go ahead and say, well, we'll call this L for length. This is the length of our box. And we can say that this is the sort of the depth, we'll call it width of our box. And then this is the height, H, of the box. So the base, this is actually the base down here. That's the bottom of the box, okay? So when we think about the base is the bottom. So that means that the volume is equal to the base, and the base is length times width, and then times height. So it's length times width times height. That makes sense, right? So I'll use a different color for surface area. So S is the surface area. So if we want to find the surface area of this box, we want to find the area of the front plus the area of the back plus the area of the right side plus the area of the left side. This would be maybe where we want to paint the box completely. Plus the area of the top plus the area of the bottom. Now if we look at the front and the back of the box, I'm going to group them together because the front and the back of the box have the same surface area. And the two sides have the same surface area. And the top and the bottom have the same surface area. As a matter of fact, let's write what they are in red. The surface area of the front, this is the front of the box right here. What's the surface? Can anyone tell me the surface area of the front of the box? Length times height, that's right. Yeah. You can say we'll put then is height times length. Height times length. This one is also height times length. Back and front are the same. What about the area of the side? What's the area of this side of the box?
Height times width.
We'll use Jillian's width times height. Width times height. Order doesn't really matter. It's multiplication. And then what's the surface area of the top or bottom of the box? Take your pick.
Length times width.
Length times width. Length times width, right? L times W. So the surface area of this entire thing, since the front and back are the same, it would be 2 times the height times the length, plus the two sides are the same, so 2 times the width times the height, plus, well, the top and bottom are the same, 2 times the length times the width. So there we have it, and we highlight it. This is the surface area of a rectangular solid, and this is the volume of a rectangular solid. So that's our first 3D object, surface area and volume. We're just going to keep going through these, okay? The next one, we add a page below, is we have another object, and this object is going to be a right prism, okay? So when we talk about a right prism, it's a three-dimensional object whose sides are perpendicular. And so this will be a triangular prism. So here's the base. Actually, I want to turn the straightener on. Here's the base of my rectangular prism. I'm going to try to do this in 2D. That's the bottom of it, right? And I'm going to copy this. There's a way where I copy it. And now I'm going to paste it. And there's the top of it. And then the sides are going to be perpendicular. So these are the edges of the sides here. So there's this one back edge that you wouldn't actually see, but I'm making it transparent. Can you see how that is three-dimensional? I hope you can see this. This is a 3D. This is a three-dimensional 3D right, and it's right because the sides are perpendicular to the ground. Prism. And this is actually a triangular prism, so this is a triangular base prism. And we need to work out its surface area. And let me grab this. I'm going to pull it down a little bit. I have it a bit high. Okay. So when we're looking at any kind of right triangular prism, matter of fact, let me just go back one page. This box is actually a right rectangular prism. The base is a rectangle, and the sides are perpendicular to the base. And here, this base is a triangle, and the sides are perpendicular to the triangular base. So if we want the volume for this is equal to its base multiplied by its height, the surface area of the base times the height. So if we want to figure out the surface area of the base, well, our best bet is to drop down a perpendicular. So drop down, say this is the altitude, and imagine if this is perpendicular. It's I kind of have it twisted at an angle. Imagine that's the altitude of the base, all right? And so I'll call this A for altitude of the base of the triangle. And I guess I should go back to blue. Okay, so this is A for altitude of the base of the triangle. This we'll call little b, represents the base of the triangle. And h is the height of the solid prism. So finding the volume for this, we have to take the surface area of the base, which is 1/2 the triangle's base times height, which is AB, multiplied by the height. And I think because I should probably do this. Let's call this a capital H instead of a lowercase h. So if I use letters representing base and height for the bases of a solid, I'll use lowercase letters. If I'm talking about base and height of the actual whole 3D object, I'll use a capital H and D. So this would be times a capital H, and that's the formula for our volume of a triangular prism. So now I'm going to go, I think my second color is black, right? So we're going to go do the surface area in black. Surface area is usually a little bit more work, right? Because we need the area of the top plus the area of the bottom plus the area of the sides. So we could say the area, there are three sides, area of side 1 plus the area of side 2 plus the area of side 3. So we could say, let's go back to blue, that this is I guess we could say that the side 1 is the front. So side 1 is the very front. Side 2 can be the right side, and side 3 could be the back, the part that's really the back. Right, so the back is like back here. So it's back there. Okay, so I'm going to go back to black. So we know that the top and the bottom are the same. So the surface area of, it'll be 2 times the surface area of that triangle. That gets the top and the bottom. So 2 times, and you know those 2's are going to cancel out, 1/2 ABH plus, well, the front of the box is height times B, right? The right side is the height times, oh, wait a minute. We have to figure out this side of the triangle, right? And this side of the triangle, right? No, but here's the altitude, right? And this is B, right? So we, in order to do this, would actually need trigonometry to do this, which is actually the next section. So I think we'll hold off. Well, not really. I think if I ask you for the surface area, you could use Vela's formula, and I'll give you all 3 slides. Does that sound reasonable? Okay. So at this point, so for the height, if I give you all 3 sides, we definitely need these sides, so I'd have to give them to you. So let's say the sides are, we'll call this side C, and we'll call this side D, right? And so the front is H times B, and the right is H times D, and then we have H times C. So there we go. Because those are just rectangles, right? And so the surface area, the 2 times the 1/2 cancels out, so it's A, B times H plus H times B plus C plus D. This works out to be H times A times B plus B plus C plus D. So we're going to have to work out. And we're going to use logic. We're going to add up all the sides, find the surface area of all the sides. Okay. The next object we're going to have is a sphere. So I'm going to add a page below. And again, we're in 3D. So this is not a circle. We're 3 dimensions. And we're looking at a sphere. Oh, a sphere is a little bit challenging to draw. So, okay. So here we go. Here's our sphere. Maybe think of it as sort of a globe. Think of it like there's the North Pole. Maybe if I do like North Pole, right? Imagine this is our Earth. Right? We could even throw in a little bit of an equator here. So I'm going to throw in the radius. The radius would be somewhere like at the center of the Earth, coming out to the edge. That's R. That's our radius. Okay. I probably shouldn't give R an arrow. R just comes out because it doesn't continue on. It's a line segment. So I'd say that's R. Okay. So when you actually get to calculus, you'll be able to derive this. But the formula for the volume of a sphere is 4/3 pi times the radius cubed. And you just have to remember that for now. And of course, pi is an irrational number, 3.14159. It actually goes on forever, never repeating. And we have that in our calculator. Does anyone know the formula for the surface area of a sphere? Anyone remember? The surface of the sphere is 4 pi r squared. Interesting, because we know the surface area of a circle is pi r squared, right? So if you have 4 circles with the same radius, that's enough surface area to cover a sphere. It's one way to help you remember. So here's our sphere, and there are more, so I'm going to add a page below. That's it for sphere. There weren't any calculations. Seems quite, after all the calculating we're doing, you might have expected more, but it's not. Yeah. Okay, so the next one is a cylinder. So we're in 3 dimensions, and we have a cylinder. A cylinder has a base that's a circle, and I'm going to have it, it's going to look kind of elliptical shape because I have it standing up, right? So that's the base. I'm going to copy the base, and because I want to paste it to get the top. Okay, so there's the top, and here are the sides. Okay, and so the volume of a cylinder is its base times its height. It's pretty standard. They all seem to be this way. The volume is base multiplied by the height. And we talk about the base. The base is the circle, right? The base is this circle right here. What's the surface area of the circle, circular base? It's pi r squared. Of course, we need to know r, so I should probably throw that in there. That's r, right? And I should also give the height. This is the height. I'm going to use a capital H because we're talking about the height of the 3-dimensional figure. So the base is pi r squared, and the height is h. And that's the formula for the volume. The volumes are usually a little bit easier to determine than the surface area. Now, to find the surface area, what I'm going to do is I want you to imagine that we took this, and I'm going to make it a little bit smaller. I'm going to shrink this cylinder down. It's going to disappear for a minute because right now I'm resizing it, making it a little bit smaller. Okay. And I want you to imagine that we took this cylinder and we said, okay, I'm going to take this cylinder and I'm going to take a pair of, maybe it's a metal can, and I'm going to cut down the metal can right down the side. I'm going to take a pair of like metal scissors and cut down the side. And then I'm going to cut open with a can opener. I'm going to cut off the top. Maybe you're going to use your metal scissors too. And you're going to cut the top off. We cut off the top, cut down the side, and we cut off the bottom. Now the 2 bottom pieces will come out as circles. And then we can take the side, and if we take the side and open it up, we take the side and stretch it out flat, we'll have a rectangle, correct? So let's do that. So if we open this thing up, we'll have, first of all, we're going to have a circle. That's the top. And we'll have another circle. That is the bottom. And then we're going to have a rectangle like this, which this is like this. And this rectangle is the sides. And we wrap that rectangle around to form the outside of the cylinder and put the top and the bottom on. Do you follow? Now, let's label some of this. I know that the circle has a radius. So both of these circles have radii, have a radius, or radii. Okay? I also know, I'm going to move these circles over to the left just a little bit because I want to put the height in. The actual height of the cylinder is h, and that is how, that would be the height of this, right? That makes sense because we have to wrap it around and it has a height h. Does that make sense? My question is, it's a little bit of a mind bender, I want you to think about that, is what is this length? How long? Yes, wow, that's really good. It is. Usually it takes people just a few minutes to get that. It's 2 pi r. The length of this is 2 pi r. It's the circumference of the actual circle. It's 2 pi r. Does that make sense? Because it has to wrap around the top. Okay. So if we want to find the surface area, S, right, we need the area of the top plus the area of the bottom, of course they're the same, plus the area of the side of the cylinder that we wrap around. And the area of the top and the bottom are the same. So it's 2 times the area of the top will give us the top and the bottom. And the area, of course, of the top is what? What's the area of the top? Pi, right, it's pi r squared. And the area of the side, it's this side, right? It's 2 pi r times h, right? So it's 2 pi r, which is the length of the rectangle, times the width, which is h. There we have it. That's the surface area of a cylinder, with the volume and the surface area of a cylinder. The next one we're going to do is a cone. So I'm going to add a page below. And we're back, we're still in 3D. And we're going to find the surface area and volume of a cone. So the cone, if you think about it, let me draw the base. The base of the cone is actually round, but it looks elliptical because I have it sitting flat. All right, so here's the cone. And the cone, just think this is like an upside down ice cream cone. Okay. Last one. The cone's base has a radius r, and the cone also has a height. Here's the height. That's also the altitude. It's come down perpendicular like that. And we'll call it h for the height. Now, if we want to find out the volume of the cone, it's interesting because if I had a cylinder, if I actually had, let me copy this base, copy, and paste. All right. If I actually positioned this so that this cone fit exactly inside a cylinder, I should think about that. Here's a, oops, let's stick with the same color. I don't want this to get too busy. But here's a cylinder, right? If I had a cylinder with the same height h, and I put the cone exactly inside it, right? And let's say I actually had the cone face up. So maybe you have a glass or a can, and then you make a paper cone and you put that paper cone into the can. So the cone and the can have the same height, and the opening of the cone, it's the same flat surface area as the can. You follow me? Then if you poured water into that cone and then dumped it into the can, it would take up 1/3 of the volume of the can. Always. Always. So, in fact, and I want to dash this is just so you can kind of visualize it, is if I know that the volume of a right circular cylinder, I already did it, as a matter of fact, that was a previous one. Oh, I'm sorry, I just hopped out of there. I did it right here. The volume of a right circular cylinder is base times height, right? It is the base times height. And what I'm telling you is that a cone is 1/3 of the volume of the cylinder it sits in. So it's 1/3 base times height. So this is equal to 1/3, and I'll just write the word base, the base times the height. And so the volume is 1/3, the base is pi r squared, and the height is capital H. So there's the formula for the volume of the cone. The surface area, we actually have a worksheet on the surface area, but let me kind of see if I can summarize it here so it makes sense. I'm going to copy this. It'll disappear for a minute and resize it. It's a little bit big. I wanted to make it a little bit smaller because I actually want to diagram the surface area in black. Okay, so if we have the surface area, the first thing we want is, Manny, you with me? Is the base. Here's the base. And actually, let me straighten that out. Here we go. Here's the base. It's a circle, right? Now it's the sides. The side of this is a larger circle, like this, with like a slice of taken out of it, like this. Looks like a Pac-Man. That's the sides. Okay. And what you would do is you would actually connect, you'd actually connect this side here to this side, so stitch it together, pull it up, and it comes up like a tent, and it would sit right up on top of the base. Can you follow me on that? Okay. So, matter of fact, okay, so how would we figure out the surface area? Well, the surface area of the base is, well, here's R, right? So this surface area of this is just pi r squared. That's pretty straightforward. The surface area of this second one is a little bit different. I can tell you what its radius is. If you were to, if I said, well, what's the radius of this whole thing? I mean, you'd have to go all the way around the circle, like that, right? And let me move this. So I want to know what is this equal to? And so let me just do this. So if I want to know what is the circumference of the outer big circle, it's going to be 2 pi times big R, where big R is this right here. This is big R. It's the radius of this big circle before we took a chunk out of it, right? So all the way around would be 2 pi times big R. But in fact, the part of this circle that actually sits on the base is right here. This blue is a part of the circle that actually sits on the base, and it is 2 pi little r, because this has to sit on this circle. This is the part that has to be glued. Do you see what I'm doing here? That has to be glued to the circle. So it is 2 pi little r, right? And then we have big R. Well, big R is actually this. And we have to calculate it. Let me go over here. Big R is what we call the slant height. And as a matter of fact, can you see how that would be big R? As a matter of fact, let's call it that. This is called the slant height. And you can get the slant height by using the Pythagorean theorem. Because if you look at this see this little triangle going on here? The base is R, the height is H. R squared plus H squared equals S squared. So we can find the slant height if we have the height of the cone and we have its radius. Does that make sense? Okay. So, so if we want to find out what is the surface area of this? Okay. It is the surface area of the entire circle, but only a percentage of it. So the surface area of this entire circle is pi big R squared, or pi big S squared. That's the surface area of the entire circle, right? But we only want a percentage of it. And what percentage do we want? We base it on the circumference. We're only taking a circumference of 2 pi r over a circumference of 2 pi s. See, this is the circumference. This top one is the circumference of the little circle, just the blue around here. And the bottom one is the circumference of the whole thing. So if we take their ratio, we have a proportion that represents the proportion of the surface area that we're taking for the sides of the cylinder based on the entire circle. So I can do some canceling out here. Of course, the 2's cancel out, and the pi's cancel out, and this. I switched it to S. I changed the R to an S because the book called it slant height, and I called it big R, and I better call it slant height like the book. So this big R's gone. I just replaced it with S. Okay. So this reduces to pi s squared r over s, and of course now the s's cancel out, right? So this s cancels out one of these, and so this ends up equal to pi sr. And this formula is in the book, and we have a worksheet on this. So if you feel like you don't really understand this, not to worry, because you will, because I have a worksheet where we're going to build cones, okay? So the surface area for this is the area of the base, pi r squared, plus the area of the sides, which are pi sr. And that's the formula for the surface area. It takes a little while to wrap your mind around finding the surface area, but there's the formula. And again, I have a worksheet on this that will help us to better understand it. Okay? I have only one more three-dimensional shape. This next one is a prism. It's a pyramid. Okay? So I'm going to add a page below, and I'm going to draw a pyramid. Okay? So again, this is 3 dimensions, 3D. And this is a rectangular pyramid. It has a rectangular base. Rectangular based pyramid. This is probably the longest video I've made so far. Okay, so here we go. Here's the base. Actually, here's one side. This is the base. Okay? And I separated them because I'm going to copy and paste. I want to make the sides parallel. That's why I do that. Copy. Okay, so that's the bottom. And so I want you to think about this. And actually, hold on 1 minute. I'm going to make the base a perfect square. I think that'll make it a little more manageable. Here's the front, and here's the side. It is a perfect square. It's just that I have it at an angle. If I made it a flat square, this is going to be 3D, so I have to make it look like you're looking at it from an angle. Okay, so let me copy and paste. This is going to be our last figure. I'm going to move this over. And as I do this, I want you to imagine you're pitching a tent, and this is the base of your tent, okay? And you're pitching this tent, and in the very center of the tent, just come on video. Okay, in the very center of the tent, here's the tent pole, all right? That tent pole sits right on the center of the tent. And now from the top of the tent to each corner, here we go, I have a side. There's one side. There's the back side, the back of the tent. There's the right side and the front of the tent. Can you see how that's a right, it's a squared base, rectangular base pyramid. Make sense? Okay. All right, so let me move this over a little bit and give you the equation for the volume of this. The volume of this pyramid is actually equal to 1/3 of the volume of a right rectangular solid that it would fit perfectly in. If I had a right rectangular solid with the same base, and let's say the base is s in the front and s in the back, the base is s squared, it's a perfect square, and then I say that the height, this height right here, which is the height of this sort of red pole, that's h, is the height. And so the actual, if it's a right rectangular solid, it's base times height, so it's s squared times h. And if it's a pyramid, though, that fits exactly inside that right rectangular solid, it's 1/3 base times height, 1/3 base times height. But the base is a perfect square. So we know the base is s squared, so the volume is 1/3 times s squared, and the height is h. So this is the volume of our right rectangular squared base prism. To get the surface area, what we need to do is we know that the sides of this are made up of 4 congruent triangles. So if we draw the altitude to one of these triangles, and I'm going to do that right here. There it is. There's the altitude of that triangle. And I'm going to call this altitude, well, we can call it A. It is actually the altitude of the triangle. And it comes down 90 degrees to this triangle. What you're also going to notice, though, is if you came out straight this way, it's also, maybe I should call it C, not only is it the altitude to the side triangle, it is the hypotenuse of an inside triangle that has legs H and S over 2. So we can use the Pythagorean theorem to find this value A. All right? So let's go ahead and find the surface area. The surface area is 4 times the area of our triangles, which our triangles area is 1/2 of base S times height A. 4 times 1/2 is 2, so it's 2 times the side length S times A, which is the altitude of the triangle. Oh, we also have to add in the base, S squared. Let's not forget that. That's the whatever we also have. I forgot about the base. Plus S squared, which is the base. In fact, we'll go back to the original. Not only the 4 triangles, but also we have to have the area of the base, which is a perfect square. And what we get is a surface area, which is S squared plus 2 times the length of the side times the altitude of the triangle. Okay? And that concludes this section on 3-dimensional figures and their volumes and surface areas. Right? Quickly, we looked at a pyramid, we looked at a cone, we looked at a cylinder, a sphere, and a right triangular prism, and a rectangular prism.
Attention, please. Can I have your attention, please? Meeting for today is canceled. Meeting for today is canceled. Also, there is no mountain training tomorrow and Thursday.